This presentation is about numerical ability of children with Down syndrome in correlation with external factors. A number of investigations have recently been made to determine the numerical attainments of children with Down syndrome. Knowing how to count and solving simple arithmetic problems are two elements of basic number skills essentials for daily, independent living. Such skills are often areas of difficulty for individuals with Down syndrome. The affliction, also known as trisomy 21, is a genetic disorder caused by the presence of a third copy of chromosome 21. Down syndrome is the most common chromosome abnormality in humans. Though the severity of difficulty varies from child to child, it is typically associated with cognitive delays and learning difficulties. The resulting variation from both biological and environmental factors impact the academic achievements of these children. Sloper et al. Examined the educational attainments of 118 children between the ages of 7 and 14 with Down syndrome. They used a multivariable analysis and found an association between the academic achievements and mental age, type of school, gender, father's locus of control, and chronological age. Social class was not found to be related to academic achievements, although it was related to mental age. Generally speaking, the number skills for children with Down syndrome appear to improve with age, similar to children with typical development, but because some variation exists, wide individual differences are noted in all studies. For now, the relationship between achievement levels and mental age in Down syndrome children remains unclear. Findings are inconsistent, but this may reflect the variety and generality of the measures used to assess the number skills. Ni et al. Conducted a research study involving 22 children with Down syndrome and 20 children of typical development and concluded that there is no significant difference in the development of procedural counting ability between the two groups. Becker and Sachs researched the number skills of 90 individuals with Down syndrome between the ages of 11 and 70 years and discovered significant effects of social class. Also of note, only 18% of the sample could count beyond 20, and roughly half of the group could solve simple addition problems. Reinders et al. Argued that both misinformation and scant amounts of available data concerning the educational potential of children with Down syndrome have led school teachers, psychologists, and other personnel to have low educational expectations for these children. Furthermore, a lack of available research concerning the numerical abilities of these special children in Greece presents a difficulty in defining any type of expectations. It is hoped that the correlation between numerical abilities and other factors will provide guidance for the parents and professionals. As for the objective of the study, students with Down syndrome may develop mathematical abilities at a significantly slower rate than others. Because of its difficulty, there is a wide range of possible achievement. Much of the difficulty relates to the inherent nature of mathematics. It relies on understanding abstract concepts that are not easily grasped by those with an intellectual disability. Mathematical skill development is also hampered by factors related to a child's gender, chronological age, other health problems, and family characteristics. The aim of this study is to investigate the importance of each variable to the development of mathematical skills by children with Down syndrome. As for method and research design, initially we conducted parents by epistle to share the nature of our research and to ask for their assistance. All who agreed to participate were asked to complete a questionnaire. The descriptive study shares the result of those surveys. Teachers participated by tracking student progress with numerical attainment checklists. Participants: the children in this study were those with Down syndrome between 7 and 14 years old and enrolled in special school programs. The group comprised the entire number of children with Down syndrome in Attica's special primary education. As for research tool, numerical ability supplemented by the teacher's experience, we used the academic attainments checklist arithmetic subscale as a source of information for our study as it applied to the mathematical skills of our test group. The material is intended specifically for use regarding children with Down syndrome and is based on a measure developed by Lawrence in a separate reading study among children with the affliction. In order to reflect the range of abilities that could be expected in primary school-aged children with Down syndrome, the checklist was designed to cover early stages of pre-reading, number writing, and other advanced skills. No standardized measures that covered such a range were identified at that time. The checklist is a criteria reference assessment comprising 3 separate subscales covering reading, writing, and numeracy, and are aimed to be completed by a teacher who is most familiar with an individual child. The early mathematical competence of children with Down syndrome was determined by the standardized psychometric criterion for early mathematical competence of Utrecht. It is a tool that is both reliable and valid in terms of its content and conceptual structure. As for the descriptor variables, first of all we would present child-related variables. Participants were asked to complete a self-reporting questionnaire for the study. The surveys addressed 3 specific child-related variables: gender, chronological age, and health problems. The total list of the items is listed in Table 1.1. As for parental and family-related variables, to supplement the information regarding the child-related issues, questions were also asked regarding certain elements of parental and family-based issues. These addressed 10 applicable variables: parents' chronological age, profession, number of siblings in the family, marital status, parental status, educational level, type of school, social class, parent in employment, and car ownership. A large amount of our statistical analysis was used in an attempt to investigate the relationship between the numerical abilities and mathematical competence of children with Down syndrome. This screening relied on the selected child and various parental, socio-economic, and demographic factors. The types of variables determined the statistical methods used for the testing. The different hypotheses needed to clarify the existence or non-existence of relationships concerning each child's attainments. The definition of the dependent variable was based on the scores of the academic attainments checklist. After proving that the dependent variable is distributed normally, as seen in Figure 1, we were able to test the linearity between the questionnaire scores as they compared to the mathematical skills of the children and other related parameters. The introduction of categorical variables was done with dummy variables having assigned values of 0 and 1. The numerical ability of children was formed at 31.83 in the 22 to 66 range, with a standard deviation of 7.92 units, and indicating a low level of performance. The distribution of the comparison of the numerical ability is shown in Figure 1. Table 1.2 presents a scale recording of the descriptive measures of numerical ability and mathematical competence for the children with Down syndrome. It shows the averages standard deviations, maximum and minimum values, and the skew and kurtosis of the distributions. The determination of correlations between the studied scales and other continuous or ordinal variables was performed through the Pearson correlation coefficients and the Spearman rho. The results of the tests are shown in Table 1.3. The statistics became significant at a level of 1% with a positive correlation at rho equals to 0.444 when compared between the scores of the Academic Attainment Checklist and the Utrecht Early Numeracy Test. There was a moderately positive correlation found between the numerical ability of children with Down syndrome and the number of children in the family, with a Spearman correlation coefficient of rho equals to 0.333. This correlation shows statistical significance at a level of 5%. Moreover, the mathematical competence of children with Down syndrome highly correlated positively with chronological age, with a Spearman correlation coefficient having a value of rho equals to 0.606, with a p-value less than 0.01. The statistical hypothesis testing of students' independent sample t-test studied the effect of bivalent characteristics, such as the child's gender, presence of other health problems, social class, parental employment, relationships, and parents' car ownership status, in comparison to the numerical abilities of mathematical competence. In regards to the numerical ability, setting the checks at a significant level of 5% showed a statistically significant effect on gender, with the girls having a higher average of numerical ability than the boys. Statistically, the other characteristic had little significance in association with the children's attainments. The results of the hypothesis testing of the separate variables are shown on Table 1.4. Similarly, for mathematical competence, the checks at a significance level of 5% showed a statistically significant effect only on the gender, with girls on average forming higher levels of mathematical competence than boys. Again, statistically, the other characteristics were not significantly associated with the mathematical competence of the group. The results of hypothesis testing are shown in Table 1.5. The one-way ANOVA method of factor analysis was used to verify any potential relationships between the measure scale of mathematical competence and numerical ability with parental educational level. Again, using the significance level of 5%, the tests did not reveal any statistically significant effects of the educational level of parents of children with Down syndrome in any of the scales. The results for both of the numerical ability and mathematical competence are presented separately in Tables 1.6 and 1.7. The continued analysis for determining the mathematical attainments of children with Down syndrome attempted to create a multivariate model that would include those variables that established both numerical ability and mathematical competence. This indicated a quantitative relationship between the two factors. To better define the data, a multiple linear regression model was used. In this equation, numerical ability and mathematical competence are the independent variable y, and the other measured characteristic constitute the independent variables. The independent variables used in the multiple linear regression models are those that were found to have statistical significance in the previous univariable tests. Thus, with respect to the numerical ability, we were able to use gender and number of siblings as predictors, And in regards to mathematical competence, we were able to use gender and chronological age. As shown in Table 1.8, the coefficient of determination for the model of the process is relatively low. Nevertheless, the hypothesis testing with the criterion F at a significance level of 5% confirmed the suitability of the model. Considering its existence and the number of siblings in the family, the model's inclusion of the child gender variable is statistically significant at a level of 5% after controlling the case through criterion T. In contrast, given the existence of the gender variable model, the variable regarding the number of siblings is not considered statistically significant when A equals to 5%, and should be excluded from the model of multiple linear regression. Interpreting the results and rates for the dependent variables sampled in the model, it was found that the numerical abilities of children with Down syndrome varies by 5.56 points between girls and boys because the number of children in each family remained the same. The numbers increased by 2.5 points for each additional child in the family from a cross-reference made between children of the same gender. The condition of the method solidified the reliability and accuracy of the multiple linear regression results. The normality of the model's dependent variable and the equivalent residues of the process is controlled by the non-parametric criterion Kolmogorov-Smirnov test, and the dependence of the residues is also channeled through the non-parametric criterion of the flow control. Following the same analysis for the dependent variable for mathematical competence of children with Down syndrome as that of the independent child's gender and chronological age, an equation of multiple linear regression can be created, as can be shown. The coefficient of determination for the process model is equal to 0.371, which is relatively low. However, in this case, the hypothesis testing via the criterion F at a significance level of 5% confirms the suitability of the model. The participation of both variables child's gender and chronological age in the multiple regression model is considered statistically significant at a significance level of 5% after controlling for each case separately through criterion T. The interpretation of the coefficient from the analysis of the model's dependent variables found that the scores of mathematical competence varied from 0.253 units between girls and boys that have the same chronological age, and because reference is made between children in the same gender, the numbers increased by 0.018 units for each additional month of chronological age. Finally, with respect to the conditions of the multiple linear regression methods, residue regularity with the process is controlled by the non-parametric Kolmogorov-Smirnov test, and the dependence of the residues is found by the non-parametric control flow test. Sloper research emerged to prove the crucial fact that parameters affecting the academic attainments of typically developing children also influence the attainments of children with Down syndrome. As a result, these designs should be considered when designing instructional interventions. The significant effect of gender shows that at this level girls have a better grasp of basic skills than boys. Our consideration have agreed with the established findings for both population of children with Down syndrome and typically developing children. Current political discussion concentrate on the lower educational success of boys, and it seems that non-egalitarian traditional concepts of gender roles are linked to lower educational success. Boys with traditional gender role patterns report themselves as being more alienated from school than girls and tend to have lower grades. As can be shown in both the quantitative and qualitative aspects, boys often display higher amounts of school-specific avoidance according to learning motivation, and spend a greater amount of time focusing on leisure activities than girls. In recent decades, the gender gaps that discriminated against girls' education and achievement and opportunities for higher education have reversed. These developments are partly attributed to the educational policy measures which is ordered to alleviate gender-related educational inequalities, almost exclusively promoted female advancement. Recent statistical data from large-scale assessment have revealed systematic deficits toward boys with respect to their performances and potential opportunities for achieving high-quality educational certificates. Additionally, of significance is the positive correlation between the academic attainment checklist and the standardized Utrecht Early Mathematical Competence Test. It should also be mentioned that the academic attainment checklist positively correlated with the Kaufman assessment battery for children from an earlier study that Nick conducted in children with Down syndrome. So the current research reinforces the hypothesis of the construct validity of the non-standardized test as a measure of numerical ability. As Ni already discovered, through the academic attainment checklist, we can access the knowledge that teachers have about a child that may not perform to his or her best ability in a simple test situation. Interestingly, the positive correlation of chronological age to numerical attainments indicates that children with Down syndrome gain abilities over time. From a developmental perspective, there is no decline in the trajectory of development in mentally challenged children who progress at a slower rate. A larger number of siblings in a family also has a positive effect on individuals with Down syndrome. Interaction with siblings provides unique learning opportunities. There are indications that the peer involvement may contribute to the cognitive development of the afflicted children. Van Rieper's study on siblings adds a fascinating aspect concerning how families respond to the multiple challenges associated with raising a child with Down syndrome. In addition, Kaskeley's study of siblings defined their role in the participation of the majority of caregiving activities. Several studies have dealt with the importance of child mental age, the various behavior problems of parents, and the overall life satisfaction of the married couple. It would be both interesting and important to apply these parameters to Greek students with Down syndrome. For a broader and more informed application, further work is required to determine how basic numerical skills are developing and how the design of different programs can aid their development, as such talents are of basic importance for independent living. Parents are likely to have a greater impact on their children's development than professionals or other adults because of the greater opportunities for providing support. The basic aim of the study is to encourage parents and teachers to have higher expectations in finding improvements in their child's functioning. It is important to share any and all factors that are significant for the development of a child's numerical ability. Research has shown that the reduction of the mother's stress level arising from their responsibilities for care and management of a child with Down syndrome can be achieved through specific intervention.